Alrighty, welcome back to our Solving Inequalities in Unit 2. Today we're doing Lesson 20, which builds off of what we were doing last time in Lesson 19. We were creating inequalities and finding solutions to them, and today we're going to practice a little bit more about how to write and solve inequalities. And so our objective for today is that I can write and solve inequalities to answer questions about a situation. So moving forward, we start off with Karen getting dinner from his drama club on the evening of his final rehearsal. The budget for the dinner is $60, right? Highlight our key information that we've been doing all semester. We know that his total budget is $60. Karen plans to buy some prepared dishes from a supermarket. The prepared dishes are sold by the pound, and so we have $5.29 per pound. He also plans on buying 2 large bottles of sparkling water, so we know that 2 is significant, and at $2.49 each. Represent the constraints in the situation mathematically. If you use variables, specify what each of them mean. And so when we're creating our inequality, we know that, think about it the same way we normally create our equalities, an equation, right? So I know that this total amount is 60. So we know that his total amount is $60. He needs to spend at most $60 because he has no more budget to fulfill. So it has to be less than or equal to. And the question is, what is it less than or equal to? And so his budget comprises of his prepared dishes, which are $5.29 per pound. In this scenario, you remember, ask yourself what is missing. I don't know how many pounds he needs. I don't know how many pounds he needs for this dinner party. So that's going to be my variable P. I also know that he plans to buy 2 water bottles, which are $2.49 each. I know that we're buying 2 of them, so I need to multiply that by 2. And remember, always define your variable. In this, I do not know what P is. P for me represents the pounds of prepared food that he can buy without going over budget. Right, in this case, we have 60 being our budget. And so the question is then, how many pounds can Karen buy? And so there's a couple ways of finding the solution to this equation, and that's what we'll be practicing today. So one way you can go about this is, simplify your equation. Multiply first, do our first step, 5.29p plus 2 times 49, which gives us 49 times 2 is $4. Oops, sorry. $4.98, still less than or equal to 60, right? And then my next step becomes, all right, how can I isolate P? So I want to subtract $4.98 on both sides of my equation, right? I'm subtracting it from both sides of my equation, and I'll write it like that, 4.98. That gives me an equation of 5.29p. It has to be less than or equal to our 60 minus 4.98, which gives me 55.02. Last but not least, then divide on both sides, because our operation that we see here is multiplication. Like I said, this is very familiar from how you solve equations. Not much has changed, but it's going to be a different idea of what the solution is. And so in this instance, if you divide by 5.29 on both sides, you're going to get P is less than or equal to 10.40, which means that I need $10, not $10, sorry, I need 10 pounds and 10.4 pounds of prepared food. I need less than or equal to 10 pounds, 10.4 pounds, so that I stay within budget. So this is a whole solution set, and I've introduced solution set before, but all numbers, right? There's multiple numbers here, right? Multiple pounds, multiple amounts that Kieran can buy. Kieran can buy to stay in budget. Oops, to stay in budget. Right, so there's multiple amounts that he can buy. He can buy 2 pounds, he can buy 4 pounds, he can buy 7 pounds, and he will still remain in budget. So moving forward, then in the next activity, you are taking a look at the gasoline tank and figuring out what possible values of X, right, are solution set, the number of hours that Han can mow the lawn without refilling the motor, right? Think about if he has a 5-gallon tank and the lawnmower uses $4 for every gallon of gasoline, how do we create our equation? And then once you write that inequality, explain what that inequality represents in the situation, right? What does X represent here? X here represents the number of hours. And so you use that as you are solving your equation. So I'll leave that for you to do. In the slide here, we give 2 examples of Priya and Andre doing different ways of solving inequalities. And so what Andre does is he solves it as an equality, right? He turns this into an equality and get X equals 3. And what he does is he substitutes, he wants to see if X equals 4 is a solution to the inequality. So he substitutes it back in, equality. He substitutes it back into the equation, and he realizes that he gets the answer 19 is less than 14, which is not true. And so he knows in his solution set, X equals 4 is not in his solution set. And therefore, the solution must be less than 3. We know that X has to be less than 3. So one way of going about solving inequalities, I showed you one method before with just keeping the inequality itself, but you could turn it into an inequality and then test numbers to see if it is true or not. And so Priya did the same idea, but switch it up a bit. She also solved this as an equality, as an equation, right? Equation in this aspect. And what she notices is that at this point in her equation, right, 4x plus 3 equals 18 minus x, this number will always be positive. Right, if you have a positive number, you'll get closer and closer to 0. But if you get a negative number, then you are still in the positive, right? 18 minus x will always be positive. And so then the question then becomes, what situation must you have, right? For this inequality be true, X must include negative numbers because this contains negative numbers. And so X must be less than 3. These are 2 different ways to find solutions to the equation. Either way can work for you, right? I don't expect you to do one certain way, but find out what way of solving linear inequalities is best for you. And so here's some practice working through how can you solve these inequalities. And so remember your goal is to isolate your variable, isolate X, isolate P, and see how you can solve it. So work it out, and we'll be talking about it in class as well. Last but not least, we talk about solutions graphically, right? When we have our solution, what does that represent graphically? We talked a bit about that yesterday. And so when you have your inequality, remember a closed circle means that it is less than or equal to or greater than or equal to. In this situation, this is all numbers less than or equal to 2, right, as you can see here. And, right, the arrow can extend way past this. And so you want to find out how you can solve your inequalities to find the correct solution and what that looks graphically, right? This means X is less than or equal to 2. You can see from another graph that you have X is greater than 0, greater than or equal to 0. And so see where you can find that solution. And so that is the goal of this lesson. And so if you have any questions, of course, reach out, and also read the lesson summary to get an idea of, right, this is another solution path of going through it. So there's 4 that we talked about in this video, and if you find one other that works for you, then feel free to do that, because I will see you in lesson 21.